The ICE borehole ROV is a remotely operated submersible machine that is part of a major research project led by NIU's geology department. When complete, it will be deployed in the Antarctic for scientific research. The ROV is being designed and built in Northern California at DOER Marine, a submersible and robotics firm specializing in the development of underwater vehicles. Here, they'll turn an idea on paper into a fully functional, remotely operated vehicle, and a storage container into a command center.
We're designing a vehicle to be dropped down through 1,000 meters of ice through a borehole, and then to deploy itself and explore the region of the ice shelf where the ice comes in contact with land, a region they don't know much about.
The ocean in general is one of the last frontiers on Earth. Antarctica is definitely a last frontier, so it's just very interesting to be able to go to a place that most people would never even dream of going, and explore a location under the ice shelf which really hasn't been studied at all, so there's great possibility of new science.
The big challenge is getting down through a limited access, a small hole. This is 22, 24-inch diameter hole, and then actually being able to carry the instruments and deploy the instruments necessary to take ice samples, to take rock samples in a fairly deep operating environment as well. So the idea was we made a long vehicle to get down through the hole in the ice, and then it would reconfigure itself, deploy to the under ice configuration that allows it to maneuver and take samples and do its work. An additional criteria is that if there was a power failure or a system failure, that the vehicle would not stay in that sub-ice condition, that it would redeploy to its through ice configuration and be hauled back through the hole just purely by its umbilical, by manual labor at the surface.
We're taking electronics to pressure, we're taking it to cold. You're going to be down in Antarctica. Are you really going to be able to replace this part if it goes bad? So design it so you don't need to. Design it so it works.
Custom made all the way, almost every component. We planned initially to purchase off the shelf, but because of the constraints that we had to manufacture almost every component.
When the engineers have finished the design, complex schematics are printed out, and most of the parts are built in-house.
What I have to do is take that design, put it into my computer. I go through the programming of the part. That part then gets put onto a machine. I grab various tooling. That tooling then goes into the machine. I set all the tools. I tell the machine where to go, what to do, and let it happen.
The engineers upstairs will design the parts and hand them off to Robin. Robin will make the parts in the machine shop, and then they hand it off to me, and I put everything together, make sure everything fits. If they don't fit, I have to either go up and talk with the engineers and have them redesign, or figure out some ways to shave and form the parts to make them fit together and work correctly. Well, right now, as you can see, I'm constructing the frame assembly. I've built some sections already, and it's just going on from there. I'm building part by part, and when more parts come along, then I'll fab them up and get them structured and ready for welding, and I weld them up, and then from there we go into more of a construction and assembly process. So now the ball's kind of rolling. So once I finish the frame sections, then the hydraulics will be put in and more mechanical pieces. So it's slowly being built up now to a finished product.
I think everyone's realizing how important Antarctica is as an environmental indicator of what's going on with the world today. And there's, a lot of concern and desire to understand what and how and why things are happening.
It's been a taller order than I think most other vehicles are, and it's certainly, as an engineer, makes it a lot more rewarding because you're making something that is different. It's the challenge and the passion that you put into it that's going to make it work.
And we're looking forward to actually getting out there and deploying it and learning what's down there, because it is interesting to go down to places that we have no knowledge of.